Alright, hello and welcome to Math World. Alright, let's talk about exponential functions. So we kind of learned it in class that the exponential function is written as a sequence, where we say the sequence of this geometric sequence with the nth term, so some random term, can be written as the first term multiplied by this common ratio, so whatever our pattern is basically, raised to the power of whatever term you're looking for minus 1. Okay? And this also can work when we have an x and y plot where maybe x is 0. If we have x being 0 and we have a starting amount, let's start with the number 5. 5 is a fun number. We actually get to write it as an exponential function with y equals, like we used to with quadratic and linear. In this case, we can say that y is equal to 5, kind of like our y-intercept. It's our starting amount. And we're going to multiply this by, pick a common ratio, it doesn't matter. Let's do doubling. Doubling is pretty easy. So if we said our common ratio was times 2, we would then have it raised to the x power. Whereas if x was 0, we wouldn't do anything at all and we get our 5. If x was 1, well then this is 2, and we do 5 times 2, 10. And if x is 2, well then 2 raised to the second power is 4, and 4 times 5 is 20. If x was 3, we'll do 2 raised to the third power, which is 2 times 2 times 2, or 8. And 8 times 5 is 40. And look over here on the y side, you see it is doubling, 5, 10, 20, 40. And let's go ahead and raise 2 to the fourth power. 2 times 2 times 2 times 2 is 16, and 16 times 5 is 80. And again, we get a doubling. So it works. We have our sequence up here, and here's our exponential function. Notice that this way only works if x starts at 0. If x starts at 0, and we have our starting term with an x of 0, we can just go ahead and have x. Now, if we don't have a starting term of 0, maybe this is gone for some reason, and the sequence starts at 1 and 10, well then we got to kind of do a subtraction thing here where we're subtracting 1 from our term, because the first term doesn't do any multiplying, it's just 10. Well, if we got rid of 5, I guess I should change this to 10 over here, right? So if this was 10, we would actually have to subtract 1 because our first term is 10 and x is 1 is 10. So a little bit tricky there whether or not we need to have that minus 1 or not. But basically if we start at 0, we can just raise our common ratio to the xth power. Alright, now doubling is very simple. Let's see what other things we could do with this. We can go up by a percentage. Maybe you start at 10, something is maybe $10, and it goes up by, let's say, 20%. If I want to increase this thing by 20%, well then I need to actually multiply by 1 to keep the 10, 0.2. If I multiply 10 by 1.2, I will indeed get a 20% increase. Let's see, let's go ahead and say 0 and starts at 10. Well, after I multiply it once by 1.2, I will get 12. Let's raise this to the x power. So a 20% increase is shown as a common ratio of 1.2. If I multiply it again, well, 12 times 1.2 is a little bit harder to do in your head, so I'm going to go ahead and go to the calculator and see what it is. 12 times 1.2 gives me 14.4. And so I get a y of 14.4, and I can keep doing this, multiplying by 1.2. Let's say I want to jump ahead to a future value, maybe 10 years away, or whatever my x value is. 10 terms down the sequence, I want to know what y is. Well, I simply put 10 into my exponent. Now here's a fancy little trick with the calculator. You can change your calculator on your computer from standard to scientific. So I'm going to change it from standard to scientific, and now I have the ability to use exponents. So I'm going to go ahead and take 1.2, and I'm going to raise it by using this little x, y. That's going to raise it to the 10th power. And I'll hit equal, and look at that. We have 6.1, but then don't forget to multiply by the first term. I almost forgot that. Times 10 will give me 61.9. And so we get 61.9 after 10 years. We see that this original $10 has gone up substantially, up to $61. Let's see, so we got doubling. If we want to triple it, we can make the ratio 3, right? If you wanted to quadruple it, you can make the ratio 4. If you wanted to make it a percent, like maybe a 50% increase, we would just make the ratio 1.5. That would be a 50% increase. And the last little thing we can do actually is we can make it get smaller. Imagine I wanted to start at 100, and I wanted to make this 100 get smaller. Maybe a 25% decrease. How can I show a 25% decrease? Well, 25% decrease means that I need to basically subtract 25% from 100% and multiply my 100 by 75%, or 0.75. If I multiply 100 by 0.75, let's see, here's our starting value, and I do it once, I'm going to get 75. That is a 25% decrease. Here's our exponent, and if I do it again, so raise it to the second power, I'm going to need a little bit of help with that. What is 75 times 0.75? It is 56.25. So there's another 25% decrease. And I can keep doing this. I can do it again and again and again, and I can go way down farther. Let's go all the way down to the 5th term. So again, I'm going to enter my 0.75, it's my common ratio, and I'm going to raise it to the 5th power. And I get 0.23, and don't forget to multiply by 100. It's a common thing to forget that. Multiply by the first term, and I get 23.73. So, what was that number? 23.73. So after 5 years, this would be all the way down to $23.73, or whatever we're keeping track of here. So notice I can make it get smaller by multiplying by a number less than 1. It's going to make everything get smaller. And that's pretty much the three different ways to see common ratios in exponential functions. You can see it as a double, triple, quadruple. We can see it as a slight percent increase, like 1.2 or 1.5. Or we can see it as a decay, actually gets smaller by multiplying by a number less than 1. It'll make it get smaller. That's pretty much it for exponential functions. Don't forget your first term. And that's it, and I'll see you in class. And now for a word from our sponsor, Papercut Games. This week's game is Clue. Now, Clue is an old game, a classic. You may have played it already, but it's pretty fun. I played it for the first time since I was a kid a few weeks ago, and I enjoyed it still. Basically, in this game, you see this game board that you'll have these little pieces, and everyone picks a character that they're going to be in the game, and it's like a little murder mystery. So you'll pick one of these characters, and they're kind of like iconic, Miss Peacock and Mr. Green. And you'll get these cards that are a person, a weapon, and a place. And through kind of guessing and asking people what cards they have, you're trying to figure out who's the killer, where they committed the murder, and with what weapon. You have to guess all three. And so the answer will be in this little confidential thing, and when you think you know, you'll look at it and try to get it correct. So it's a fun little murder mystery, and it's pretty fun to play with the characters. And it's pretty iconic. As you see here, they made a movie about Clue. I'm sure it's horrible. And here's even Lego Clue. So it's been around for a while. So if you haven't played Clue, get the family together and give it a try. I like Mr. Green. I'm Mr. Bigsby, and I approve this message.